This is example 4 of the Solving Exponential and Logarithmic Equations lab. We want to solve for x from the following equation. We have log of base 6 of x plus log of base 6 of x minus 9 is equal to 2. So we want to solve for x, so we want to combine our x's from here and here. And notice that we have the same base of 6 for both of these logs, and they're being added. We can use the product rule to combine these logarithms. The product rule is log of base a of m and m times n is equal to log of base a of m plus log of a n. So right now it's in this log of base a m plus log a of n form. You can see we're having two logs of the same base that are being added right here. So we can combine these into log of base a of m times n. So by multiplying these two, we can write them under the same logarithm. So using the product rule, on the left-hand side, this is the equivalence of log of base 6 of x times x minus 9 is equal to 2, using the product rule. So I'm going to multiply this through. So you have log of base 6, x times x is x squared, x times negative 9 is negative 9x is equal to 2. And now that we have done this, we want to put it into, we want to get this x squared minus 9x alone. So we need to get this out of a logarithm. And the way we do that is we're going to put it in exponential form using this equivalency formula right here. So if you have log base of b of value p is equal to m, that's the equivalence of b to the m is equal to p. So we're going to find what our b, p, and m are and then put them in this format right here. So, marker. We have our b is equal to, our p is equal to, and our m is equal to. Look at our formula here. Our base is b, so our base here is 6. Our value is p, so our p right here is x squared minus 9x. And our m is what is equal to this 2. So now we're going to use our b, p, and m and write this in exponential form. So, exponential form, we have b to the m is equal to p. So our b was 6. Our m was 2. And it was equal to our p, which was x squared minus 9x. So we've successfully rewritten this logarithm into exponential form. So now we're going to rewrite 6 squared as 36. And then we're going to subtract 36 on both sides. So we have 0 is equal to x squared minus 9x minus 36. And now we're going to factor x squared minus 9x minus 36. So 0 is equal to x. So if you don't remember factoring, we look at negative 36 and we look at factors of those that multiplied are equal to negative 36 and added are equal to negative 9. So those factors are negative 12 and 3. Notice we have negative 12 times positive 3 is negative 36, and negative 12 plus 3 is negative 9. So that's how we factor that. So, taking each of these and equaling them to 0, we get x is equal to positive 12, and x is equal to negative 3 from there. But we need to check both of these answers to make sure they work in the original formula. So, taking that, we had x is equal to 12 and x is equal to negative 3. And our original equation was log of base 6 of x plus log of base 6 of x minus 9 is equal to 2. So we're going to substitute each of these x's into this equation and see if they work. So for x equals 12, we have log of base 6 of 12 plus log of base 6 of 12 minus 9 is equal to 2. And you'll find that there's nothing wrong with this statement if you put it into a calculator. It doesn't go beyond the bounds of a logarithm. So now for x minus equals negative 3, if we substitute x equals negative 3, we have log of base 6 of negative 3 plus log of base 6 of negative 3 minus 9 is equal to 2. And now we see a problem. This problem right here is that this one and this one have logs that have a negative value inside of them. And we cannot have that because logarithms have to be log of anything, let's say of value a. The a has to be greater than 0. And the reason that is for example, let's say, first of all, it's beyond our domain, but I'll show it to you in exponential form so that you kind of understand more why intuitively. So if we have log of 6 of a negative number or 0, negative 3, for example, which is what we had before, is equal to some number, let's say b. In exponential form, translated to this is 6 to some exponent b is equal to negative 3. And there is nothing that b can be to make this statement true. If b is 0, then this 6 would change into 1, which would not be negative. If b is a negative number, it would just simply turn it into a fraction, if you remember your exponent rules. And if b itself is a fraction, it just means that this would get smaller, etc. So there's nothing that b can be to make this equal to a negative number or for it to be equal to 0. What I just said was same as if this negative 3, if this was a 0, we had 6 of b is equal to 0. There's nothing this b can be to make this statement true. So any logarithm for some number a has to be greater than 0. It cannot be negative, it cannot be equal to 0, simply because this state, it's an impossible situation. So, because of that, our only solution, we had x equals 12 and x equals negative 3. Our only solution is x equals 12. We cannot have x equals negative 3 as a solution.